Hi, everybody. I hope you can hear me fine, and let us know in the chat if it's not the case. Yeah, I'm very proud to be here today because I'm allowed, or I can talk to you about things we've been working on for near half year now, and a few people have seen things we've done so far, and we made a bunch of announcements, but this is the first time I ever get to talk about what we've been doing, and I think we have some cool stuff to show, and yeah, that's why I want to get started. These things are usually pretty impersonal, so I'll put up a photo here so you have an idea who's talking to you. This photo is actually 5 years old, and I'm wearing glasses now, and my beard is much longer, but this is roughly how you can picture me. So just so you know. This is Couchbase in PHP, and we've had other webcasts before that talked about Couchbase in Java and .NET, I think, and there's way more information about what Couchbase itself is, so I will give you a bit of an introduction just to give you enough ideas to learn about the PHP extension that we have for you, but I will not in detail explain what Couchbase Server is or does. And there's plenty of other information on our website at couchbase.com. There's videos and full documentation. Half a book is written. Lots of stuff for you to find out all the details about Couchbase. But for now, all you need to know is summed up here. It's a distributed, queryable, persistent document database, and that's a bit of a mouthful, so let's go through the individual things here. It is a distributed database. Well, there's a lot of different, a lot of people have a lot of definitions for what a distributed database could look like. Our definition roughly is that we believe that it is a good idea to have a logical database, a thing that holds your data, not live on a single computer or a single machine, a single server. Other databases are very good at being a database that lives on a single server, but with all the virtual machines that everybody's using and with failable hardware, having more than one machine to hold all your data is a very good idea. And while I mentioned hold all your data, data volume has grown exponentially, and single machines are just not capable of storing and making that much data available. So having more machines is a good idea. Distributed for Couchbase means it is very easy to add more computers to your database or to the database cluster to give it more performance, more capacity, and give it more data redundancy for data safety. I'll give you a bit of an idea of how that looks later, and talk a bit about not the caveats, but what you need to keep in mind over a regular database that lives on a single server that you might be used to. Queryable means it's a queryable database. Hey, what else should, like, why is this a valid point on a database? Of course, a database should be queryable. I wouldn't be a database otherwise, would it? There is other distributed data stores that allow you to store data and retrieve data and in a very simple fashion, and they're also distributed and they scale well and they can hold a lot of data, but they're not very flexible as in how you can access your data. You can usually can't make smart queries or do other fancy things with it. We figured out a way, like we're not the only ones that did that, but we figured out a way to build a distributable query system so that you actually can make meaningful queries across all these computers that run your data. I'll go into more details in that later, like how you prepare your data to do this and how you run the queries. It's also a persistent database. That's also a bit of an oddball point here. If you're a hardcore database guy, of course, like it needs to store data. Why else would it be a database? It would be a cache otherwise. The history of the project includes a project called memcached, and the primary way of accessing Couchbase is actually the memcached protocol. But everybody, I hope a lot of people or everybody here is familiar with memcached, has at least heard of it. it is usually associated with an in-memory cache, so it doesn't store any data. So that's why we feel it's important to add persistent to the point here. And there's a lot of other NoSQL databases that are just in RAM or mostly in RAM, and the thing there, which is also great, but it's not what we're doing. We allow you to store your data persistently, and we guarantee that it's all stored and you get it back, and we don't corrupt it and everything. And it's a document database, finally. It's a bit of a wishy-washy term. There is no scientific definition of what a document database is. I'll show you a bunch of documents later. And think of it as a way to organize your data when you're programming. You usually have some sort of a model object or just objects that hold data, or a little bit more high-level data structures like arrays or hash tables. They can be thought of as a document, and then like a self-contained entity that expresses a thing, whatever your application needs. I'll show you a few later and how we work with them as well. You'll learn more about that as well. So I hope that clears up the introduction, what a distributed queryable persistent document database is a little bit. Again, to find out way more about the database server itself, go to couchbase.com. There's a nice introductory video on the homepage. Don't go there now, of course. Wait, we can just wait. I think it's 3 minutes and 15 seconds. I'll just wait until you're done watching that one. No, let's not do that, sorry. But you should watch it right at the end of the screencast. I did a screen grab for you. This is one of the screens inside that video, and it shows roughly how the architecture of this looks like. At the bottom, you have 3 nodes or 3 computers that make up your database cluster, your Couchbase server. And at the very top, you have your application or an application thing, the code that you wrote that is user-facing, that does the thing that you need done from your code, for your application. And in the middle, there's a thing that says Couchbase library. I'll show you, tell you a little bit more about that in a bit. But this is roughly the setup. And if you're used to, say, MySQL programming in PHP, you have a PHP server on the one side, and maybe you have a master server situation there. You have a libmysql-based PHP extension running, which then talks to, is accessible by your application. So the setup is very, very similar here. The only difference is here that our server characteristics are a little bit different, so you can actually have multiple servers and they act as a single database. There's a few interesting bits about the Couchbase extension. We call it libcouchbase, and it's the thing right in here. And I go through the bullet points. It's a smart client. That is actually only relevant if you're ever looked at earlier mem-based product or earlier versions of Couchbase. If you're not familiar with that, don't worry about it. It is a distinction that we made between dumb clients and smart clients, and PHP finally now has a smart client because we believe PHP programmers should have a smart client. If you don't know what the difference is, don't worry about it. I'll put it. The only reason I put this first is that we make sure you get the best available client technology to use with PHP. Next, libcouchbase is asynchronous. It means that instead of you run an operation that gets sent to the server, you wait for the server to reply, then you wait for the reply to be processed and then made available in libcouchbase. What we do is you can collect a bunch of operations, send it to the server, collect a bunch of more operations, send them to the server as well, while the server is processing the first batch. Then the server can return the results of the first batch and return that back to your program. You can do stuff in your program, and then the server can return the next batch, and this keeps on going. This means that no part of that setup is ever waiting on any other ones, and we can process a lot more things. If you look at other asynchronous programming languages, there's Event Machine for Ruby or Node.js. They work in a similar way. They expose all that to the programmer. The cool thing is that you don't have to change a thing with libcouchbase and the PHP extension we built on top of it. just works like you would. Like I'll show you code in a second. It'll just work like you expect, but under the hood, you get a high performance asynchronous interface. And if you really need to, you can actually make use of that yourself, and to do more advanced things. Like that's an example for that later as well. But for now, you don't need to learn any new programming paradigm or anything. So we did all the hard work for you. It's high performance. We're very we didn't plan for that exactly. Like we wanted to make it efficient, but we did some preliminary benchmarks, and other clients that can be used with our server is our libmemcached based. It's a client library that's built by the open source project libmemcached, and it's a very good library, and there's a lot of things great about it, but we decided to start over for a number of reasons. And it turned out that we actually, for simple benchmarks that we did so far, we're actually twice as fast. I don't want to make a broad statement that we're always twice as fast. There may be other reasons where we're a little bit slower, but we're at least in the right ballpark of performance that you would expect from a high performance and low latency database. So, yes, it is, like I said, it's rewritten from the ground up, and one of the reasons that we didn't base this work on libmemcached is it's been in the making for a while. I think the memcached started in 2003, and even if it doesn't look like much on the outside, the C and C++ languages evolve significantly. We get new compilers and new platforms. Things need to compile on Windows, on ARM, and then on Windows. Alongside the regular like x86 or x86-64 platforms. So we started with fresh code that wasn't bogged down by any old conventions that weren't matching the real world anymore. And this also means, and we put an extra emphasis on this, if you've ever tried to use, and God bless you if you have used or tried to use memcached on Windows, with PHP, there's a lot of pain involved there. So we set out to solve this for our side, and actually have code for you that runs on Windows as well. We know a lot of developers are looking into that, and with Azure, Windows is becoming more relevant on the server again. So yay, we did that. And since we were there anyway, and we were talking the same library, the same protocol, we put in another treat that if you're not actually not at all interested in Couchbase, you should, of course, and I hope you are. But if you just need to talk to a memcached server, you can do that as well. So we'll actually put that, like we found that would be useful for the open source community. We don't derive any business value from it, but this will make it a lot easier for PHP developers to just use memcached. And then, of course, subsequently we may hope, or we hope that you may exchange that server for a Couchbase server at some point, but there's no strings attached. I don't have a slide for that, but it should be obvious. I hope all of this code is open source and Apache 2.0 licensed, so there's no license restrictions on it anywhere. It's not proprietary code. You can even hack on it. We already have a bunch of contributors that help us there. We even have somebody from the Perl community who came over and just wrote an extension for Perl, Boo Perl, of course, but we're very open to contributions on this. And if you like what you see and think, hey, there's a thing missing, or this doesn't work just quite right for my use case, maybe I can fix that. You can find all our code on GitHub and help us make it better. And yeah, I hope you can do that. That can help us here as well. Let's move on. A Couchbase cluster is a little bit different from a single database. I've mentioned that a few times now. And there's a few things that come with it. In the old days, if you use memcached, and again, if you haven't, I'll skip over that really quick. You could use it with multiple servers, and it would allow, okay, just use half the data on the one server and half the data on the other server, and you had to use add server to manually maintain the list of servers that were active, and you need to, from your script, need to detect if that particular server was offline at some point, maybe it crashed, so don't send any traffic there anymore, and fire up another one, or figure all the things out that need to be figured out when the server dies or goes away. And if you want to increase capacity and add more servers, all your data needs to be redistributed, and it's usually general really big pain in the ass to get that going. you have to do none of that with the libcouchbase based extensions with like the PHP extension. Like I said, Couchbase makes it easy to add new servers and remove servers and do other things. But all of that is completely transparent to your PHP application. You just connect to the server, you write your data, you read your data, you make queries, all the things you need to do. And if anywhere in the meantime or in between a server dies because of a hardware failure or of a virtual machine failure or because of a network failure, or if you want to add capacity at runtime, say one of our clients is running a very popular iOS application, and we basically start out with a big cluster, say maybe 18 servers, and then it turns out during the day they get new press and a lot of people start using it, and we just add more nodes to that, and I don't know, by the end of the day, maybe 36 nodes in there, and then we fire up another cluster that handles all the load without the client ever having to rewrite their application. So we can just do all sorts of scaling magic in the back, and even when say popularity declines a little bit, or you make things more efficient otherwise, you can just remove nodes to accommodate your downscaling needs. So that's kind of nice. But again, none of that is ever visible to your application, so we completely abstracted that away, and that's actually pretty cool. So yeah, I said these things you can scale up transparently and scale down as well, which is useful. Say you're something like Netflix, there's a lot of stuff in the evenings, but maybe not in the mornings and over the weekend, so you can be dynamic about when to have a lot of computing resources available and when not. And like I said, it's all transparent. You never have to see any of that. That is roughly like all the cool things that you can do with Couchbase. There's lots more, of course, but yeah, like I said, this isn't a talk about Couchbase itself. Again, go to couchbase.com to figure out what we have done there. I'll finally go and show you a bit of code, and we'll walk through this slowly. First, for naming, the PHP extension that we wrote on top of libcouchbase is called Couchbase, and if you're familiar with the PHP world, that's how you get more functionality for a specific database. Again, code is up on GitHub, and we have binaries available and everything. So yeah, it's really easy to get started. I'll run through the setup in 2 slides, and then we'll just put a comment into the code that assumes you have done that. On couchbase.com/develop/php/current, we have the current stable release, and there's also a next release that is for the upcoming server for you to try out. And we have precompiled binaries for Linux and CentOS and Fedora and Mac, and I think one more platform, and different 64 and 32-bit versions of that as well. If you don't fall into that category, we also have a source download, and if you've ever installed the PHP extension from source, that's available as well. I think Windows is coming really soon. Maybe even tonight. I'll be maybe working on that later. Once you've downloaded the SDK, like we call it, you end up with a folder that has an SO file in there, and all you need to do is, or shared library in there, and all you need to do is add to your PHP ini the line extension equals couchbase.so, and you're ready to go. So we assume you've done that to get started. The next thing you do is in your code, you create a new database handle called, I call it CB, because all the other databases usually use DB, so we're a CB because we're Couchbase. We're a bit different. What you do here is just create a new object of the type Couchbase, so this is a class that we do, and pass it a connection string. And this is just an HTTP string that the server talks for administrative purposes. You can put in username and password, the host where this is running, and we're currently running a local host, and the support, and the name of a bucket. And down here, it's the parts I explained in a little bit more detail. If you're not a fan of object-oriented PHP, there's also just a procedural API if you prefer that. You create a new handle and pass that to the subsequent functions like you would be used to from other extensions that have a dual interface. They all work the same, whichever mode you prefer. There's no difference in performance or anything. It's just a matter of style, and whichever you prefer you can use. To go through the connection parameters here, user and passwords, of course, secure access to your database. It's always a good idea to only authenticate or give the user that is your application, only give that so many rights as it needs to run the application, but maybe not to administrator the database server. Leave that for the administrator. You put in the host name of the server and the port. And finally, the name of a bucket. And a bucket in Couchbase is what a regular database and a database server is called a database. MongoDB has a collection, I think. It's where data gets put that belongs together. And if you want to use a different one, put a different string over there. Yeah, I think that is all about to get a new connection to the server. This is all you need to do. And if you, even if you have multiple nodes here, this line of code will initialize the PHP extension to be able to talk to all the different nodes. I see a question pop up, so I'll have a look at that real quick. Maybe I can have to answer that. Okay. I'll leave that for later if that's cool, because it's not really on the topic, but I will be answering that later. I won't forget it. Thank you. Let's get started to do something useful, finally. 23 minutes in. You see the way of I structure these scripts. Like I put a comment here that says setup, that assumes we've done the setup, and we have a CB variable that we can use to talk to the server. In this case, I just have some data. It's a string that I want to store, and I need it later. And I need it available to under the key my data. The key here, the first argument to the set method, is similar to primary key in a relational database. It's that one name or number that you want to be able to find your data back on in all cases. There's also other ways to query it, like you can query a relational database, but for now we just store this key, and you can actually choose. With MySQL, you can also choose, but you usually use something like an auto-increment ID that just gets bigger and bigger and bigger, and there's different problems with that. With us, you can just define what we want here. But then the one restriction is that these keys need to be unique, so there can't be any other data in Couchbase that also has the name MyData. There's only one. Once I've stored this string, the method returns true. We don't check for this. This is very bad programming, of course, but I hope you get the idea. Later, we want to get that data back, so I'll use the get method on the Couchbase object and put in the key that I used earlier over here, and I get my data back. And if I print this or if I echo this out, I'll get my string back. That's very easy. So this should be pretty obvious how to get and set stuff. I'll continue on with the API. I'll mute myself for a second to get a drink. Don't be worried. Okay, I'm back. Nice cup of tea. I have new data here that I want to store. Foo. Foo's always important to store. You should always have a foo around in your database. Then, instead of using set, we also have two modes called add and replace. And again, if you use the memcached, this is exactly the same. The add method here allows you to make sure that you only ever store. The set method will unconditionally just store the data. If that key already exists, it will get overwritten. If it doesn't exist, it gets created. If you're in a situation where you want to make sure you only ever add new data instead of accidentally overriding data, you can use add. For example, if you want to start a counter and you want to start at 0, or if the data is already there, don't override whatever the counter number is or the value of the counter is with the initialized 0. You can use add, store that data, and if the data already exists, that call will just fail. No big deal, and you know that data is already there, and you don't override it accidentally or whatever else. The flip side is useful as well. Only replace data. If it doesn't exist, don't create it. So if you just want to, you want to make sure you don't accidentally create data, you can do that as well. There's valid scenarios for all of these. Now I'll show you the first minimal version of how to store a document, and there's more elaborate examples later, further down. For now, a document is just a JSON string. Up here, the first few lines. We manually construct a JSON string. There's a foo and a bar, and they have the values 1 and 2. And I can just store that string using the set method as usual, and Couchbase Server will internally understand, hey, this looks like JSON. I will make this available as JSON to the server and for subsequent operations. I assume most of you don't want to actually deal with hand stitching together JSON, so I don't. There's a very easy way to do this. You just can instantiate a standard class, or if you have any other native or any other object, you can just use that, set the member variables of that object to the values, then call JSON encode on that data, and the same thing happens. It gets encoded into a JSON string and gets made available as JSON on the server as well. And because that is tedious as well, because you just want to store objects, I don't care about what the database wants here. There's even an auto-serialization mode that you can look up in the documentation, where you just pass in native values and object, and Couchbase will convert that into JSON for you, so you always know that you do have JSON on the server. So why that gets more useful, I'll show later. But this is to give you a first taste of how to store structured data here. Get delayed is your one interface into the asynchronous nature of libcached and Couchbase by proxy. The syntax is again very similar to memcached. The idea here is that you want to get some data, but you don't actually need it right now. So maybe at some point further down in your PHP application, your script, you need that data. You can already start out by starting or asking the server for that data and defining a callback function that then gets called for you when the data is available. This is useful in all sorts of situations. And this is one example of how to use this. You just get delayed just works like get, except you are passing in an optional parameter here that is the function. With newer PHP versions, you can use anonymous functions in here, which makes it really cool and concise to write these as well. And there's also, we need to set the webcast parameter here that I haven't shown you before to the default value. I'll get into that in 1 or 2 slides. What that is, for now ignore that, but this is just passing in an optional parameter here. And then the rest of the script continues, and at some point the callback here gets called. That's not the question. I'll have a quick look. Let's see. Yeah, I'll be looking at that later as well. I'll go through this first. These are high-level questions. I'll be answering them later. If there's any questions that are right on the topic that I'm talking about at the moment or was previously, I can answer them in line. CAS. Hey, we saw that the slide earlier. I'll explain it. CAS is short for compare and swap, and it's a pretty universal concept that when you store a value under a key, you also, during the storage, that value gets associated a CAS number or a CAS value, which changes with every time you write the data. In our case, it's a 64-bit integer, and you can access that data with the get method here. Again, you pass in a null extra parameter that we don't have to worry about for get. So we want to get my data, don't care about this one, and then we pass the CAS variable by reference. It's a very C-ish approach to programming, but this is if you have memcached compatible code running already, this is the exact same API, so you can get started or you can migrate your code without much pain. So there may be a little bit old school concepts here. But the point here is that what you can do now is set my data to the new data that you want to have stored as, and then call cas instead of set. And as the first parameter, pass in the integer value here that we just got earlier from the get, store the key, or store the my data under the key my data, and then we assign that to the new variable is stored, and we check if this is false, the cas value for that key has changed on the server, which on the flip side means we know somebody else wrote a new value into that particular key, and then we know, hey, we may be, if we're writing this now, we'll be overriding that other data. So if you think about a wiki where two people are editing a particular paragraph or the whole page, and then maybe somebody makes a new contribution, and that takes a while, and somebody else is just sometime later while that contribution is being written, finds a typo and fixes that typo, and then when the contribution gets stored, the typo isn't fixed, and there's a race condition here. Basically, we may lose the typo fix, or there's two versions now. So this is kind of weird. And with this, your program or your application can do the right thing to figure out if some important piece of data has changed since the last time we looked at it. This is actually very useful for not losing data. I'm a big fan of this. One other thing that we associate with keys, aside from cas, is an expiry value. So you can say, hey, this key is should now be valid for 10 seconds, and after that, it shouldn't be set anymore. This is useful for all sorts of other timing-related things. And what you do here is with a set method, again, is the key, it's the value, and the next parameter is an integer that expresses seconds. So in this case, we want to expire this key in 10 seconds, and then we sleep for 5 seconds twice in a row, and then try to get the data again, and we get null back, which signifies that key doesn't exist. But if in the meantime we decide we actually want to keep that key around a little longer, we can set it with an expire of 10 again. This is the exact same code down here, and we sleep 5 seconds, but in between the other sleep, or before the other sleep, we can touch the my data key, like the Unix touch command for files, just update the X this time. We can do the same here and sleep another 5 seconds, and then when we get the data, it's still around. If we were to sleep another 5 seconds and then try to get it, we'll be in the situation of the first snippet here, where that key would be expired already. So this is rather simple as well. Append and prepend I'll do rather really quickly, I think. And because they're really obvious, they work on strings only. You can have a string ABC, set it, just store, and then there's a method called append, and we append DEF, and now if we get the data back from the key my data here and print it or echo it, it says ABCDEF. That's not big of a surprise, but this allows you to do all sorts of fun things on the server, and of course prepend works as well. We have a storage. We're storing the string XYZ over here, and we prepend U, V, and W. If we get that data back later, we get U, V, W, X, Y, and Z back. I think that is pretty obvious as well. And finally, there's increment, decrement. I talked about counters earlier, but there's more here. And counters in distributed databases are usually pretty tricky, but we solve them as well for you. So what you can do is initialize a counter, set it to 0, and then increment it. And at the first line, the counter is an integer and is 0. When you increment it, it's then 1. It's pretty obvious. You can optionally also pass in a number, which we call the offset, about how far you want to increment. So if you increment with 8, it used to be a 1, then you're at 9, and there's the counterpart decrement. If you want to go down again, you decrement by 4, or by default 1, but in this case you're back at 5. And now This isn't very interactive. You could send questions, but it may take a long time. So I put in, I made a mistake in this script because this counter isn't very useful on its own. So you may want to increment every time that script gets run, but you don't want to reset it to 0 all the time. And in the second line there, I use set to set the counter to 0. And every time that script runs, the counters get set to 0. So the final number is always going to be 5. What I should have done in this case is use the add method that instead of only setting, instead of just unconditionally setting that value, just adding it if it doesn't exist already. So if I've created this counter variable before, and if I did some incrementing and decrementing on it, I don't override it with 0 if it already exists, but keep incrementing and decrementing it to the value I want it later. So I hope you all spotted that. I trust you did because you're all very smart, I hope. The next topic here is documents and views, which is where if you're already familiar with memcached, the API should so far be very familiar to you, except maybe for the JSON document stuff. If you know this, the interesting part so far is that the server is way more capable and allows you to store data on multiple databases and everything. But now this is where the document part comes in, and views are our query mechanism. Should have explained that probably. Let's start out by looking at a bunch of documents. To describe a document, we use the JSON syntax, and it's just we would just add it is the actual data structure that the server uses, but it's also a very simple, concise, and readable way to represent an object in many programming languages, including PHP, and all important programming languages include support for JSON as well. So we see a few here. At the top, there's a user profile. There's a user ID, a password in here. Nobody remember that. Poor Alan. There's a nickname for him, or a real name, a bunch of nicknames, and a timestamp for when he signed up and when he last logged in. You already see a few things that are cool about JSON. The first thing here is that we have different types of values here. We have a string here, an integer here, or a number, as JSON calls it. And here we have an array or a list of things. And JSON just makes it very expressive for you to build rich data structures to store whatever data you need. The really, really neat part is, I keep repeating that, is if you have a data object, a model, in your programming environment, you can just convert that to JSON, store it. You don't have to think about how do I deconstruct my object to make the database happy, to get it stored somewhere. You don't need to have some heavy lifting object relational mapper piece of software that deals with how you program and how the database stores stuff. You just store stuff as you need it. Like the times of when you need to program for the database are over. You should focus on your application. We believe that's way more important. Make your users happy, or customers. One specialty you see already at the first thing, the first key here is underscore ID. It's a special field that we reserve. Actually, on the top level here, we reserve the all keys that have an underscore first, so only the database uses them. For now, and this ID here is the same key that you've seen earlier, where you used my data, the data or the piece of data at which to find your data back again. Over here on the right, we have another document that just lists a bunch of friends of Joe. Of our user. Sorry, the first friend is Joe, and there's Matt here and Tor. So this describes a friend relationship for some. For a person here. And down here we have a bunch of documents. I omitted the ID here. The ID is mandatory. It's included automatically, but here I just omitted it. We're looking at transactions from Matt to Chris, or from Matt to Perry, and then from Chris to Perry, and they all pay 30 coins to each other. That's a bit of a roundabout way of getting money, but I guess that is how economy works on a low scale. But we're just recording transactions here. Okay, so now that we have an idea of how documents can look like and how they relate to how we use the programming, let me introduce you to views, or how to query a database that stores documents. When you install Couchbase Server, your browser will fire up the administrator interface and will ask you to configure the database. There's a few forms you got to fill out and put in like the administrator password and set up the default bucket and how much memory you want to use, all these things. And it also allows you to do cluster management and a lot of other things, which you can all read about on couchbase.com. Again, this is not about the server. But one part of it is the view administration UI. And the core part of this is right in the middle, where you should be looking at this. To define a view, you need to write a little piece of JavaScript that takes as an input a single document of what you've just written. What you used, and then extract the data from that document to put into an index, and then we will be able to query that index. And I just made a screenshot from a running system over here. That doesn't have to do anything with the sample data, but this is where you can put it in your function, you can try things out. There's a show results button here. It's very interactive. It shows you, hey, does it get the data that I want? Doesn't it do it? There's a bunch of results that I can, not results, I can do, put options in here and say there's a connection timeout that's automatic, and then I only want 10 here. I'll skip 0. Maybe I want to have the next page, so I can skip more. There's a lot of options you can put in here, and I'll show a few of them later as well. And then if you have a lot of data, you don't want to create a view that looks at all your data, because say you have a bunch of terabytes data, and creating a new index is a time-consuming, of course, operation. It's like alt a table on a relational database, and just for development and for testing, you don't want to do that and pay a performance tax on your cluster. So we automatically create a representative subset of your documents. Just a few hundred, maybe 1,000, and you can check if your view code is correct and shows you roughly the results you want, and then you can enable it to run on the full cluster set. And then something that isn't shown in here, up here you can see that you can load sample documents, so you can actually match the code to what you're looking at here. But what isn't in here, there's a way to put a view or a query definition from development into production, which is a deployment step, at which point the access to that view is extremely fast and distributed, and you know that there's no other computations missing. And if there's new data arriving on the server, we will asynchronously update the particular index that runs your query. But now, let's see how this works in practice. I'll need to drink a bit first. I'm going back to very simplistic documents over here. I'll write the JSON myself. We have 3 values. The documents all have the key A, but different values, 1, 2, and 3. And all we want to do for now is just get a list here of what is all in the attribute A. In the map function, the only thing that we do is emit doc.a, but doc, not to be confused with PHP. This is actually JavaScript. This makes this whole thing more comfortable for other programming languages as well, because I think everybody can agree writing a little bit of JavaScript isn't very painful or hurts. But now we want to extend that for PHP at a later point, but currently you got to write JavaScript. But the only thing you do here is just you emit, which means put into an index the A attribute of the particular document. And we're storing this under a view group. Ignore what that is for now, under the view name list. And you just call the view method here to produce a new result. This is like your MySQL query, and you put in the SQL statement over here. It returns a result, which then lazily loads all the result rows over here and gives you an object per row that includes the key and the value. And for now, we're only interested in the key here. I'll show you the value later. And we just echo this out, and this extracts the 1, then the 2, and then the 3 out of our values here and prints this all out. This isn't very fancy so far, but it shows you how you can access data from inside a document and do other things, or do query type things with it. This gets interesting when we add a reduce function. I'm not going to go too much detail about reduce functions, but if you look at the screenshot here, there's a bunch of built-in reduce functions, and in I think 95% of the cases, this is all you need. If you need to write a custom one, you're either a super expert or you don't know what you're doing. In either way, we refer you back to the documentation about the built-in reduces. And in this case, we want to sum things up. So instead of just the map function, we define the reduce function sum as well. And the code is the same. We just add the sum function here. And if we query that result, we only get a single result back, but it's 6. It's summing up all the values in here. So with this, you can see how you can make calculations based on data here. And there's a lot of other things you can do, put out dates and then query date ranges, or calculate expenses, or bank transactions, or all sorts of other things that you can that you think about. It's not that I have to open. Yeah, that's also a general question that I'll leave for later. I'll go through that as well. No worries. So since this is a very simple example of how to use a view and calculate some aggregate data from that, I'll chose a bit more elaborate example that I hope I can still convey over 2 slides. Bear with me. What I'm trying to show here is, you've seen earlier that we created a document for a person and then a document for that person's friends. We're using a similar situation here where we have a document that defines a person, and there's an array in there that defines these person's friends. And we want to query our database, hey, give me information about my user and all their friends. And I'll be storing a new person called James here, using the key James, and I created a document here that has just an array, Simon and Ben. And this is how you will model. You don't even call it modeling data. This is how you would program. And then you have a user object, and you can just store that to the database. There's no step of how do I design my data to fit what I'm doing, what I want to do later. I wrote my own JavaScript function here, and I include that in comments because we're actually in PHP land. But it's very simple. There's a single parameter or a function argument here. It's the document we just created. The first thing we do is we create a special key. We're actually emitting an array. And the first element of this is the ID of the document, which corresponds to the name James over here. Sorry about that. The next thing we're doing is we're iterating or we're looping over the array over here with this construct in JavaScript. It's called that's a for each function that you can call in an array, and it gets passed in each member. So this gets called, this row here, basically the emit call here gets called twice, once with Simon, once with Ben, and we emit that as well. And when we're emitting an array as a key again, and we put in the doc ID as well. So we make use of the sorting nature of views, so that keys that are lexicographically the same or the same numbers are sorted. So we know all James's friends are sorted together, and then we have the name of the friend here. That's all we need to define this. Then the next code here is we're doing a query of that view. First, we need to set query options or query arguments, parameters, and that is just an associative array or a hash map. I think PHP is an associative array. We have 2 options, the start key option and the end key option, and we just define what we want. We want starting from James here, defined in this array syntax, and we want to end. Actually, that's not how PHP works. That should be like this. Sorry about that. And the last key that we want here is James, and then the higher. It's a kind of a wild card. Like whenever there's a new user that isn't James, stop looking at data here. And then we already have the familiar method call Couchbase view. We call this one users with friends. We pass in the options and get a result back. And on the next slide, I'll show you what the result looks like. I repeat for you so you can follow along. Again, the options and the call, and then I get a result that I can iterate over or loop over, and I'll just print the key. And from the key, I'll just use the second parameter. It starts at 0, of course. So we get the name of the friend, and this would then print the James at first, like he's the person, and then his friends Ben and Simon over here. We made a friend list, and if we have tons of other users in there, we can use the same structure to get all users for Ben and Simon, but for you or for Pete and Mary and whoever else is in our system as well. And making these lookups is once we've deployed our review, is very efficient and high performance. I hope this gets you started with how views work in Couchbase. Again, we have screencasts available that go in way more detail, and a lot of API documentation and regular documentation that explain how all that works, how you can use the different options, how you do pagination, and all sorts of crazy things that you could think of doing here. But I hope that is to get you interested and get started. How it isn't actually too hard to get here. That's one question actually for reviews. There's a question by William. And the question is, does the MapReduce run distributed like Hadoop, or is it on a single server only? With Couchbase, the MapReduce runs on the cluster. That means each node in the cluster has a subset of the data. Like if you have 3 servers, every server has a third of the data, and then the MapReduce runs only on the third of that particular data, and then at query time, the cluster gets merged for you, and the client can then return it to you. So it is a distributed way, not a single way. Since the introduction, or like the announcement of this webcast included information about deployments, there's actually two and a half things to talk about that I get through really quickly, and I think that we can open up for more questions from the audience. So if you have questions so far, you can think about them and write them down so we can put them in the QA panel. But I'll go through these here through this last section first. If you're building a server infrastructure, the one thing to look out for is removing single points of failure. Like the sole reason why you would be interested in having a database that runs on multiple servers is, it might be just handling all the data that you have, but if your data is important, you actually want to make sure that the data is available at all times. And Couchbase cluster, or the Couchbase server actually, lets you build a cluster that takes away all the pain of making that happen for you. There's a few more things to look out for. If you've ever used Membase before, or have used memcached with a program called Moxie, that helped you a lot along the way of getting towards a situation where you have semi-automatic clustering, but then you need to do some housekeeping left and right as well. And if you were looking into Moxie for high-performance situations, it was a bit of a bottleneck and sometimes a performance problem. And of course, it's a single point of failure, so we don't need that anymore. The other problem is that you've seen the setup code earlier. Let me skip through that real quick over here. You pass in a single node here for your cluster. If you have multiple nodes and you expect them to fail, your application may not, this node might not be available at the point where your application starts running. What you actually want to do is know about all your nodes that you want to connect to, and if that happens to be not available here, you want to connect to another one, and I'll show you the pattern for that really quick. I just want to iterate that This is only required for the setup phase, for when the new PHP process started and the script is executed for the first time. Once this is running and connected, any changes in the server are transparently handled for you. This is just the initialization phase that we also want to make foolproof. In this case, I have a list of servers defined here, and this could be maybe defined in a configuration file or something else that you maintain, or you can even automate with the deployment of your server. But so your application knows, hey, there's two servers that I should be talking to here. I'm actually doing a fancy do-while loop. I always look for an excuse to do this. And I'll try to connect to the first one. And if that doesn't work, I'll connect to the next one until I'm done, or I will be erroring out. This would be one pattern of doing this, and we're actually working on making this redundant, so you just pass in a bunch of nodes to new Couchbase over here instead of doing them one by one by hand. The alternative is here that there's external solutions to make sure that IP addresses or host names are highly available. So if a computer dies or if a server dies that is associated with a particular IP address, make that fail over to a new live server that replaces that particular database. You can use that as well. But again, this is covering an edge case, not the general situation. And again, all that magic cluster management is hidden from you. Now, there's another question. Let me quickly look at it. If it is, when do we plan to release the view support? If you look at the next version of the PHP extension, it's a bit of older work, but it shows a proof of concept of how to use that. This isn't yet the final thing that we want to release, but we're pushing very hard to get that into your hands next week. And we already have preview code, or like preliminary code that isn't really stable yet, or not stable, but not reviewed yet on GitHub. But we hope to get this into your hands very shortly. And I'll be working on this next week. The other point I wanted to make about deployments is how this generally works, which I picked two examples that are typical for a PHP installation. It's the Apache worker or a fast CGI setup, where you have a bunch of server processes, and they may be standalone PHP processes in the fast CGI case, or Apache worker client worker nodes or processes that include a PHP library. Since connecting to the cluster over the HTTP API and doing the configuration from the cluster is a relatively expensive operation, and it's still pretty fast, but as opposed to using the memcached binary protocol to send and get data, it's rather slow. We don't want to do that for each time the PHP request response cycle runs. The PHP usually solves that problem with allowing persistent connections for other databases. And if some databases are good at that, others are better or worse. For example, I don't know, back in the day, using MySQL pconnect was a bit of a problem with if you had a bunch of Apache worker processes running. Couchbase Server is powerful enough to open a good number of, or actually the current limit is about 10,000 connections per node. So even if you have a lot of worker processes that all open their own persistent connection to the server, and even hundreds of them, with hundreds of processes on there, you will not run into any issues using these connections. The upside here is that these connections are reused, and the cluster configuration can happen transparently again. So your application can be ensured to get to the data as fast as possible. So these are the deployment notes on how this works. This concludes the slide set here. And again, I hope we're just about an hour in, which I'm very good at my time and very proud here. I hope you liked it so far. There's a bunch of open questions that I'll get to in a minute. But so far, I want to thank you for listening. It was a pleasure talking to you. And I'll be saying hi from Berlin. If you have any questions, feel free to email me at jan@couchbase.com.